Hello students, how are you all? I hope you are doing absolutely well. Welcome all of you at AriserTalent. Now we have discussed about so many terms that are showing a trend in the periodic table. It means periodic trend in the periodic table has been classified according to a numerous number of terms. So in this series we have gone through ionization enthalpy and the electron affinity in our previous lecture and show how they are showing the trend in the periodic table. Now we are moving to our last term, that how electronegativity will going to show the trend in the periodic table. But before that, let's start what actually the electronegativity is. So we are starting with electronegativity. We are starting with the term electronegativity. Electronegativity is actually the ability of an element to attract a shared pair of electrons, but this shared pair of electrons will not be attracted by the isolated atom. It means there must be a bond present between the molecule. It may be the covalent bond that will exist between the atom or the molecule to attract the shared pair of electrons. So it is the property of an element to attract the shared pair of electron, but not in the isolated state but in the bonded atom. So let us write the definition here. It is defined as a tendency of an element to attract shared pair of electrons in a covalently bonded atom. So it will be the ability to attract the shared pair of electron. So here it is a definition for electronegativity. Now let us move to understand that what actually the electronegativity is. So for describing this, I am considering here two compounds. It means a compound that is made up of two elements. You can see here, this is a metal A and this is a metal B, and these are bonded by a single bond. It means if they are bonded by a bond, there exists a two electrons here. You can see here, we can note that one bond is present and the one bond will going to constitute of the two electrons, because two electrons will going to make a single bond. Now what will happen if I am considering two elements here? These two elements are going to form a compound. It means one element is more electronegative as compared to other. Now if I am assuming that B is more electronegative, if I am saying B is more electronegative, if we are saying B is more electronegative, what B will going to do? B will try to attract the pair of electrons from A. So you can see that the concentration of the electrons will be greater on the side of the B, because B is trying to attract more electrons towards it. So if B is more electronegative, then what will happen in this case? If I am drawing A bond B, there is a concentration of electrons towards the B is more. So we can say that electronegativity will be defined for a compound in which one element or the one metal is more electronegative as compared to the other. So it is all about electronegativity. The electronegativity is actually a relational property. We can write here the another statement for this. It is a relational property. Now what this statement is going to specify, it is a relational property. Relational property means when we are going to calculate the electronegativity of a compound, it came out to be a relative number. It means a fixed number for electronegativity has been obtained. So we can say that it is a relational property, because on calculating electronegativity, we will get a relative number. Relative number is obtained. Now, electronegativity is basically determined by the Pauling scale, and this Pauling scale has a magnitude range from 1 to 4, so it may be able to identify the electronegativity of a compound. So we can say that it is basically measured on Pauling scale. And what this Pauling scale is going to determine, it will have a scale ranging from 1 to 4. So its scale is ranging from 1 to 4. So this is about the basic features of the electronegativity, and again this topic is very important because increasing decreasing order type questions can be asked from this topic. Now we will see that how the variation of the electronegativity will occur along a period or along a group. It means we are going to identify the trends in the electronegativity in the periodic table. So let us consider, I'm writing it here, variation along period. Let us consider variation along period. Now, what will happen in case of variation along the period? Suppose, firstly we will consider here that electronegativity is inversely proportional to size, and electronegativity will be directly proportional to effective nuclear charge. This will be directly proportional to effective nuclear charge. So here are the 2 points which we have to consider to get an idea along a period or along a group. So you can see that electronegativity is inversely proportional to size. It means if the size decreased, electronegativity will going to be increased. And if it is directly proportional to the nuclear charge, we can say that if nuclear charge is increased, electronegativity will be increased. These 2 factors will help us to identify that what will be the trend of electronegativity along the period or along the group. So, if I am considering along the period, suppose we are going along the period. So if we are moving along the period, what we can observe that atomic size decreases, atomic radii decreases, and effective nuclear charge is going to increase. So if atomic size is decreased and nuclear charge is increased, electronegativity will going to be increased. So it is the trend along the period. So what will happen here, as we move from left to right, what will be the trend in the electronegativity? Atomic size or atomic radii decreases. If atomic radii is going to decrease, what is going to be increased? Nuclear charge will going to be increased. If nuclear charge increased, we can say that electronegativity will going to be increased. So both of these will lead to the increased electronegativity. So electronegativity will going to be increased. Now what will happen here? We know that if atomic size is going to decrease along the period, what will happen? The nucleus have a more effect on the electrons present there, because there are no much electrons in the outermost shell and there is no shielding effect. Shielding effect is actually the property of the nuclear charge that it will shield the effect of the nuclear charge from the electrons. But as the size is very small, you can see that the nucleus has a much influence on the electrons. So if it has a much influence on the electrons, the nuclear charge is going to be increased automatically, and it will lead to the increment in the electronegativity. So this is the variation along the period we have discussed right now. Now let us move to the variation along the group. The variation along the group will be just opposite to that of the variation along the period. So let's discuss. I'm writing it here. Variation along group. Now, what will be the variation along the group? If in the group, if I am going from top to bottom, we know that if we go from top to bottom, the atomic size or the atomic radii will increase. So, what will happen next? Atomic radii increases. If atomic radii increases, the effective nuclear charge will going to be decreased. Effective nuclear charge because nucleus have less effect on the outermost electrons. Effective nuclear charge decrease, and if both of this will happen, the electronegativity will going to be decrease automatically. So we can say that electronegativity will decrease from top to bottom. If we are going from top to bottom, electronegativity will decrease. Now, let's assume the periodic table. A simple description about the periodic table must clear a picture in your mind. As we move from left to right, what you can see that in extreme left, the alkali metals are present. If I am going from left to right, you can see that the halogens, that is fluorine, chlorine, these are present on the extreme right of the periodic table. And we know that fluorine is the most electronegative element in the nature. So it is proved that if I am moving from left to right in the periodic table, the electronegativity will increase tremendously. So this is all about the variation of electronegativity. Now, let us take a differentiable table to differentiate between the electron gain enthalpy and electronegativity, so that it might be very clear to you that what basically these two terms are. So let's have a look at the difference between electron gain enthalpy and electronegativity. So our next topic is about difference between electronegativity and electron gain enthalpy. We are going to discuss about difference between electron gain enthalpy and electronegativity. Now, we will draw a difference table to differentiate between these two terms. So, the first term is about electron gain enthalpy and here electronegativity. Here we are drawing serial number. Now, what is electron gain enthalpy? We have discussed previously. Electron gain enthalpy is the ability of an atom in which there is an addition of electron, but there is an addition of electron in an isolated atom. But in case of electronegativity, we will see that it may be happened only in the compounds. It means a bond must be present between the compound. So it is for the isolated one and it is for the combined state. So we can say that it is the ability to attract electron in an isolated atom. So this is its first property, and it is the ability to attract the shared pair of electron. Shared pair of electron in combined form. Now, let us move to the second difference. The second difference we have among electron gain enthalpy and electronegativity is that electron gain enthalpy can be determined experimentally and electronegativity is a relational number. So, a relative number will be come out when we calculate the electronegativity. So, the second difference is it can be determined experimentally. It can be determined experimentally and it is a relative number. It is a relative number that we have discussed, then it can be calculated on Pauling scale. Now, let us move to the next difference between electronegativity and electron gain enthalpy. Electron gain enthalpy is actually the energy, so its unit will be kilojoule per mole, kilocalorie per mole and joule per atom. But electronegativity is only a single number, so it is a unitless quantity. So we can say that its units are kilojoule per mole, kilocalorie per mole or joule per atom. On the other hand, this electronegativity is a relative number, so it is a unitless quantity. It is a unitless quantity. Now, what will be the next difference between the electron gain enthalpy and electronegativity? Electron gain enthalpy is a constant term. It means it is highest for chlorine. But if we are considering electronegativity, this will depend upon the number of factors. It will depend on what will be the oxidation number of a compound, what will be the hybridization state of a compound. So it depends upon the variety of factors. So let us move to the next difference, that is it is constant for each element, and this depends upon number of factors, and these factors are either oxidation state or it may be its hybridization state. So, this is all about the difference between the electronegativity and the electron gain enthalpy. I hope these differences has been clear to you. You can copy these differences from here. So, we can proceed to our next topic, that what will be the trend in case of the metallic and non-metallic character. So, copy it from here. So let's discuss about metallic and non-metallic character. So the next characteristic is all about metallic and now let's discuss some basics here. What actually are the metals? So the elements which have 1, 2 or 3 electrons in their outermost shell, it means they have an ability to lose that electrons, and after losing that electrons they will form a electropositive element. It means positive ions are formed in this case, and such type of the compounds are known as metals, and this type of the character is known as the electropositive character. So it is about the metals. So what will happen as we move from left to right in the periodic table? You have seen that atomic radii is going to be decreased. If atomic radius is decreasing, it means the non-metallic character will going to be increased, because as the size reduced, it will not able to lose as much as electrons as the metals do. So if I am moving from left to right in the periodic table, what is going to be increased? Non-metallic character is going to be increased. So let us understand here that how the metallic and the non-metallic character will show their trend in the periodic table. So firstly, we will see the basic description. The elements having 1, 2 and 3 electrons, if they have 1, 2 or 3 electrons in outermost shell, they lose their electrons and form electropositive ions. It means if they have 1, 2 or 3 electrons, they can easily lose 1, 2, 3 electrons. And what will be the characteristic of this type of the elements? These elements are nothing but this is the characteristic for metals. This is the characteristic of metals. Now, if the element having 4, 5 or 6 electrons in the outermost shell, so it will be very difficult to lose that electrons, and what that element will going to do? That element will try to gain more electron and try to complete its octet. So this will be the non-metals. So we can write here the element having 4, 5, 6 electrons in outermost shell they try to gain electrons and form negative ions. And if they are forming the negative ions, they are known as electronegative elements. They are known as electronegative elements. And which are trying to gain the electrons, it means they are nothing but they are the metals. They are nothing but they are metals. So this is all about non-metals. So this is the basic definition that we are dealing here is about metal and non-metals. but we have to analyze the metallic and non-metallic character along the period or along the group. So let's discuss about the metallic character here in the periodic table. Now, along the period when we are going from left to right, what will happen here? If we are going from left to right, you can see that the tendency of an element to gain the electron will be increased. It means if the electronegativity will increase, not metallic character but the non-metallic character is going to increase in the periodic table. So let's have a look at the group number 2 elements here. We can observe the group 2 elements here. Now, the group 2 will basically start from lithium here. So, I am writing the elements here. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. You can see that these are our, which are group elements? These are group 2 elements because the lithium has been starting from group 2. Now, if I am moving from left to right in the periodic table, it means if I am considering the periods in the periodic table, you can easily observe from there that these two are metals. These are metals. What about boron? Boron is neither a metal nor a non-metal, but it have a combining property of both. So, we can say that boron is a metalloid. What is boron? Boron is a metalloid. Now, let's further move to the next elements. Carbon, nitrogen, oxygen and fluorine. These all are gases and gases are counted in the category of non-metals only. So, these all are non-metals. Now, we can easily observe from the group 2 elements, we can see here as we are moving from left to right in the periodic table, here are metals, here are non-metals. So, what is going to increase tremendously? The non-metallic character is going to increase tremendously if we are going from left to right in the periodic table. So, what we can conclude here, in moving from left to right, what is increasing? Non-metallic character increases. Non-metallic character increases. And what is going to be decreased? The metallic character is going to be decreased. So, we can see that metallic character will going to be decrease. So, this is the trend in the elements that group 2 elements are showing here. Now, let us see more examples here. We are considering the group 3 elements. We are considering group 3 elements. Now, the group 3 elements are basically sodium, magnesium, aluminium, silicon, phosphorus, that is up to phosphorus, 16 is sulfur, 17 is chlorine and that is argon. So, here we have considered the group 3 elements. Now, let us see the sodium, magnesium, aluminium and silicon. We know that sodium, magnesium and aluminium, these all are the metals. So, I can write that these are metals. Now, if I am considering silicon, it is showing the characteristic of metalloids. So, it may be counted in metalloid and starting from phosphorus, sulfur, chlorine and argon, these are non-metals only. These are non-metals. So the what trend in the periodic property of the elements we are observing here, we can see that here in the extreme left side of the periodic table we have metals, and in the extreme right side of the periodic table we have non-metals. So what you can observe from here, we can easily observe that if we are going from left to right in the periodic table, the non-metallic character is going to be increased. So here the non-metallic character is going to increase. So from this analysis we can easily see that in the periodic table the metals will lie on the extreme left side and the non-metals will lie in the extreme right side of the periodic table. So this is the trend in the periodic table from left to right. Now let us have a look at the period trend in the periodic table along the group. It means from top to bottom. So now let us see the trend in the metallic properties from top to bottom. Now we are discussing along the group. Along the group means from top to bottom. Now what will happen here, if we are going from top to bottom, the metallic character will going to increase and the non-metallic character will going to be decrease. So let us have some example here. Suppose we are considering the group members like so these are the group group elements, and these are sodium, potassium, rubidium, cesium and francium. So these are the list of the elements we have in our group. Now what you will observe from this, as we are going from top to bottom in the periodic table, sodium is a metal, but if I am going from top to bottom, you can see that cesium and francium are present here. So francium is more metallic as compared to the above elements. So I can write here, this sodium is least metallic and this francium is most metallic. This is most metallic. So what will be the trend if I am going from top to bottom in the periodic table? If I am going top to bottom in the periodic table, the metallic character will going to be increased. If I am going from top to bottom, metallic character increased. So if metallic character is increased, what about the non-metallic character? It will going to be decrease. So let us have a look at the non-metallic character. Now, if I am considering the non-metallic character along the group, let us take the group 17 elements here, that is fluorine, chlorine, bromine and iodine. Now, these are the group 17 elements and these are basically known as halogens. Now, if we are moving from top to bottom, fluorine is a non-metallic compound. But if we are moving down the group, you can see that iodine is the most non-metallic compound. So we can see that if we are going from top to bottom in the periodic table, the non-metallic character will going to be increased, decreased. It is fluorine is highly non-metallic. It is highly non-metallic because it is the highest non-metallic metal. But if I am going to iodine, it is least non-metallic. So iodine is least non-metallic. So we can see that we are going from high to low. So if I am moving from top to bottom in the periodic table, the non-metallic character will decrease. So we can analyze from here that non-metallic character will going to be decreased. So this is the trend in the periodic table about the metallic and the non-metallic character. We have seen that if we are moving from left to right, non-metallic character increases, but if we are moving from top to bottom, the metallic character is going to be increased. So from this analysis, we can summarize the periodic table as, on the extreme right of the periodic table, there are metals. In extreme right of the periodic table, there are non-metals, and they are separated by the zigzag line. This zigzag line is nothing but these are the metalloids having both the property of metals and non-metals. So let's discuss about the brief description. So you can see that if this is our periodic table, in the extreme left of the periodic table, this is left side and this is right side, and this is our zigzag line. So we can observe that in the extreme left of the periodic table, metals are present. Here the metals are present, but in the extreme right of the periodic table, what are present? Non-metals are present, because the non-metallic character is going to increase here, and this zigzag line is composed of metalloids. So the metalloids will lie on this zigzag line. So we can say that on extreme left we have metals, in extreme right we have non-metals, and the metalloids will lie on the zigzag line. So this is the brief description about the periodic table we have. Now we have discussed a variety of properties here, like ionization enthalpy, electronegativity, electron gain enthalpy, and the question will be definitely asked from this topic. Either we have to show the trend in the 4 basic properties. So it might be difficult to learn these tables. So we will summarize this in a very short form. When you look for this in the exam only, you can easily go through such topics very easily. So let's have a general look at the properties that they are showing the trend in the periodic table. So we can see that if it is our periodic table, this table I am drawing here, it is for your exam purpose only. So you can easily go through this table and learn how the basic properties will show the trend in the periodic table. So you can see that this is our left to right. This is our left to right. If this is left to right, we can say that these are nothing but these are periods. If I am considering this line is from top to bottom. This is top to bottom, and top to bottom is called groups. Top to bottom is called group. In our periodic table, we have 18 groups and 7 periods. We have 7 periods in the periodic table. Now let us consider the first characteristic here that we have discussed here will be, the first characteristic we have discussed here is that the first characteristic will be about the atomic radii. It means the atomic size. So if I am saying about the factor atomic size, then what will be the trend in the atomic size? The atomic size or atomic radii in moving from left to right in the periodic table will decrease, and it will increase in moving from top to bottom. So how the trend in the atomic radii can be shown here? In moving from left to right, it decreases. But if I am moving from top to bottom, it will be increases. So this is the trend in the atomic size. Now let us consider our second characteristic, that is about ionization enthalpy. If I am considering ionization enthalpy in moving left to right in the group, the ionization enthalpy increases. If it is increases, but from moving down the group, it will decrease. So in moving from top to bottom, ionization enthalpy will going to be decreased. Now let us consider our third factor, that is electron gain enthalpy. Same thing will be followed for electron gain enthalpy and electronegativity. In moving left to right in the periodic table, electron gain enthalpy increases, but in moving down, it will decrease from top to bottom. So this is about electron gain enthalpy. Now let us consider electronegativity here. So the next factor which we are taking into consideration is about electronegativity. Now what will happen in case of electronegativity? Again electronegativity will going to increase from left to right. It will increase from left to right. And if I am going from top to bottom, electronegativity will decrease. So this is the trend that some of the periodic properties will show in the periodic table. So you have to learn this table in your exam. So it may be clear to you that how these trends will be followed in the periodic table. So we have seen a many type of properties here regarding various trends in the periodic table. This lecture is over for today. Thank you so much and have a nice day.